welcome to episode 153 of the PC Perspective podcast. I am Jared Hellstrom.
Podcast.
Yeah.
Check.
The guy whispering podcast is Josh Walrath.
153.
And any second now, you'll see Al Malventano.
I'm just making the shining sounds.
Red rum. Well, we've made it to yet another podcast in which Ryan has found a much nicer place to be than said podcast. This year, it's the Virgin Islands, where he's hanging out with his lawyer. We're not quite sure why, but we're hoping it'll win the case. You can reach us for voicemails, of which I apologize, but we don't have any this particular episode. But if you leave us more, maybe we'll get more. So that's 1-800 or 1-888-38 PC per. Or
you gotta say it all Canadian like.
1-888.
But we don't have any Z's in there.
We need a new number per A, because that'll get them a completely different number. They'll be ordering newspapers and stuff, and we've been there.
Yes, papers. That's the secret.
Because this is the thing.
Come on.
The voicemails are much funnier than the emails, but if you insist, the email is podcast@pcper.com, and you can catch us later on if you didn't get enough of us tonight at pcper.com/podcast in its wonderful new wrapper, because the PC Perspective, if you haven't noticed yet, has had a new update. So to start off with, it looks like it's still going to be me, because there's these rumors going around that I received a monitor. I didn't actually ever receive a monitor, so I have nothing to send back. I don't know who this guy is that did the review, but I'm going to cover it for him, but it's not me. I don't have it. But it is the Dell U3011, which is a 30-inch monitor that does 2560 by 1600, or if you want to annoy your TV-centric friends, 1600p. It is enormous. You just picture, a 30-inch LCD, but you're a couple of feet back, at least, if not a dozen, sitting on a couch, and frankly, the resolution on it, they're bragging about 720 pixels vertically. Really? Sitting in front of the thing, a foot or two away, imagine a 21-inch monitor switched over into portrait side with a brother directly beside it. It is enormous. And the resolution, of which 2560 by 1600 is essentially twice the pixel count of a 1080p TV at 4,240,000 pixels, produces a resolution that is frankly obscene. It's just incredible. There is a caveat to it, though. As many inputs as this does have, and I can handle VGA, HDMI, and dual-link HDMI, dual-link DVI, HDMI component in if you went that strange way for some reason, or DisplayPort. And well, technically it is possible to do it on dual-link DVI. I never actually successfully got the full resolution on anything but DisplayPort. If you fiddle around with drivers, theoretically, yeah, you could be able to do it, but frankly, what card nowadays doesn't really support DisplayPort? It's a much more solid connection than DVI, which has pins that can be bent out, and we've all spent numerous hours trying to straighten pins because the store was closed and we needed it. So really, I do suggest making sure you've got DisplayPort, because the other thing is, if you've got a mid-range video card, you are not going to push 2560 by 1600. It's just not going to happen. So,
well, you could push it, just not really game on it, though.
Well, yeah. You can watch. I looked, and there's not too many YouTube videos that can do anything like this.
GTX 460 that I've just tested recently was able to push 2560 by 1600 pretty well, and even in some titles using AA. Yeah. It's just anything kind of under that, like an HD 5770 and below. That's when things get kind of...
I've even gamed when I had a GTX 260. I've had a 30-inch for a long time, so even a 260 is capable. You can't really go crazy. You can't be like Crysis with all the settings maxed and max resolution and everything like that.
Well, no.
But But it's you can push it. It's not like the old days where you had the video card would only go to such a resolution. But that sort of thing. But what I did notice is I've never had any kind of issues with dual link DVI. Actually,
I haven't either.
Yeah, just as long as the card can push dual link. There's a couple of extra caveats you got to realize there because not every DVI cord is dual link. And as a matter of fact, I wouldn't be surprised. I wouldn't be surprised if that's maybe what you ran into because it's finicky. You have to have a good quality cable, and it has to actually be an actual dual link cable that has extra pins.
And I went with the ones out of the case, and I tried it twice.
Do you know that your 6950 it has the two DVIs? Only one of those is dual link. So did you try them both?
Really?
Yes, I did.
Wow.
Okay. And
that's surprising.
Only one of them is dual link.
Yeah, that would really.
I tried that. So I'm thinking it was the cord, or it's just the particular drivers that I took, which were like the 11 2s, 11 1s, and something back from 10.
Just out of curiosity, does NVIDIA do that with any of their cards? Like that weird, I'm not even used to seeing a card, any kind of recent card that had a single link DVI.
No, NVIDIA, it's the way that AMD does the Affinity with the latest series of cards.
Oh, okay. So it's just like
if you notice, they've got the two display port outputs.
Right.
And so they had to kind of wiggle around a few things to get those to, be fully functional. And, one of the DVIs is single link.
Huh. Yeah, good to know. I had no clue until that was just said. So
yeah, no, it is utterly true, and that was one of the first things that people suggested. So I pretty much boiled it down to, okay, it was the cable that came with it. But either way, I still found DisplayPort just a better way to do things. Apart from that, as I mentioned, there's not too many YouTube videos that do beyond 1080p, and this thing has got a decent on-screen display. I've heard that a lot of 30-inch monitors, their on-screen display is really non-existent. I don't know, I haven't seen one, but I'm looking forward to maybe doing that in the future. This, in one of its features, after you find the one that turns off the noise where you click everything, will do 1-to-1 pixels. So if you're like me and prefer the black bands as opposed to stretched video, it's really, really nice to see. There are some drawbacks to this monitor. In that this, in particular, is an in-plane switching monitor. That means that the TN monitor that you're probably used to, which is significantly cheaper, has a significantly faster response rate, and just generally you think provides a better gaming experience, is not able to do anything as soon as you turn to the side. The colors go completely and totally batty. On the other hand, on the other side of in-plane switching are the really expensive VPA monitors, vertical plane alignment, where they've actually got two control zones, and this is where you're looking at your professional level because, hey, it's got a quick response rate. Your blacks are pitch black, which this cannot do to a certain level. But subtle color changes, trying to play with, gaming, you're going to actually notice some weird fuzzing going on. In-plane switching sort of sits between that. It's got the two transistors, so it could theoretically have the two fields, but it doesn't. It just twists them very nicely. And while I was using this mostly for gaming and very much enjoying it, it is really a professional level monitor. This is actually one of the 30-bit color depth capable, or 10-bit per channel, or 10-bit per pixel, however you want to refer to it. It's about 1.7 billion colors, and it's capable of 170% of the CIE 1976 color gamut. So, if you're a professional, this thing is really what you're looking at, assuming you've got a card which can push 30-bit color depth, which the vast majority of us don't. Quadros and Fire Pros, of course. The only other card that I ran into that could do it was an HD 5970. For some strange reason, AMD decided to go that way. If you don't have a card that pushes it, then you're at 24-bit color depth, which we're very used to. That's true color. That's what we're all used to. It is technically only 16.7 million colors, not 1.07 billion. On the other hand, how realistic do you want the blood splashes of your victims to be? And I don't have the professional level card. I do have a Huey to do some color adjustments to the monitor, and as it turns out, it comes factory pretty respectable. You have to be pretty discerning to be able to tell the difference, and frankly, if you've got an eye good enough to tell the difference, you already own a Huey or a DS1 or one of the other color calibration hardware pieces, and you're not going to have to worry about it. They did stick 4 USB ports on it and a 7.1 card reader if you are of the type that you want your monitor to be able to do everything, including blow your mind. And to get right down to what the gamers care about, which is response testing. I don't really have a handy way to sit here with a, 100 picture a second camera and be able to tell you just exactly what the frame rate is. I do have some spare time, and, I kind of thought that, all right, fine. Millisecond response time is what we're looking at. So I will go and see if maybe on the internet somewhere I can find a way to display a clock that does milliseconds. And yeah, there's actually a site called Free Flash Clocks that does things like this. So on a nice bright white screen is a clock displaying milliseconds of time with the Dell on one side and a CRT on the other. This is a really nasty, horrible trick to play on a monitor because most monitors pick and choose the fastest color change of a pixel. Though they might do gray to gray, which they won't do average over the screen. They'll pick a fast portion of it to do it on. Or if they do the white to black to white, they'll actually choose, and they can do this a way that, hey, this one comes out being a lot better. Because this particular section of your screen is nice and close, and there's absolutely no delay, and hey, they don't have to go through all the colors, and it works out really nice. So I thought, all right, it's got to go from white to black to white again, and it's got to do it with milliseconds flashing on the screen. Start taking pictures of that. Start taking hundreds of pictures of that, as it turns out. But as it eventually ended up, for my CRT, we're looking about an average of 35 milliseconds, maybe a frame. It might drop a frame on you compared to a CRT. Compared to an Asus TN monitor that I have, 20 milliseconds off. So not even as bad, which I'd always been warned. If you go with a large monitor like this, especially you go with an IPS or an HIPS like this actually is, it's going to have display lag. You are going to see tracers coming across your screen and during fast-moving images, whether you're gaming or whether you're just sitting there watching a movie. I honestly did not see that. So as far as gaming goes, if you can afford this thing, absolutely pick it up. It is a brilliant piece of work. If you're a professional and you can cut someone to write this off for you as taxes or to buy it for you, start pushing them. I just got 2 warnings to say, which is the viewing angle on this thing is ridiculous. If you are standing about 5 degrees off of true of this monitor, you can still get a rough idea of what it is that the person using the monitor is looking at. The colors aren't off. It's just the fact that your eyes can't really focus on that tight of an angle. And the second is that even though this has a nice stand, it's ridiculously heavy, so it's not going to get knocked over. It's got about 4 or 5 degrees or 4 or 5 inches of travel up and down, a good 30 degrees sweep on it, and 20 degrees right to left. No portrait mode. If you want to use this in portrait, you have to buy some arms. Apart from that, I really, really don't want to give this back.
Your idea of ridiculously heavy is really different from mine, because I remember that Sony Trinitron. It was I think it was
for an LCD, not for a CRT.
Oh, okay, yeah, because that damn Sony 24-inch 1920 by 1200 monitor was like 186 pounds.
Yeah.
It was ludicrous.
I, at one point, had a 46-inch CRT TV. Easily 200 pounds. No question about it. But as far as trying to pick this thing out of the casing, the nice, helpful monitor pivot wants to pivot on you. The base significantly outweighs the screen. The screen itself, naked, is about 20 pounds. The base is probably closer to about 25, 30.
That is a lot lighter than the old, like the original 30-inch panels, by the way.
Oh, yeah.
Like even the Dell, just because now it's LED backlit, right?
Yes.
Which brings up another point. This is not an HC panel per se, but it's actually better. So everybody that's used to hearing Dell, and they look for an HC class panel because of the wider color gamut and all that other stuff, that doesn't apply anymore because LED backlit screen is covering even more of the color gamut than the
I thought this one was still a cold cathode.
No, it is an LED backlit.
Oh, okay.
Yeah. Now, the other question is if it's like red, green, and blue LED backlighting or just like white LED, but I guess you'd have to figure that out
Pure
based
white,
on what
as far as I understand.
Yeah, it's still pretty darn good, though.
Yeah.
As far as what part of the color gamut it's covering. And the calibration, you don't really have to calibrate those things much anymore. Even the old HC panels were good if you just use the default profile from Dell. You got pretty close.
And if you want, this has got Adobe RGB and sRGB modes. So if you're that picky, you can switch between them.
Yeah, and even those are really darn close. So even with my HC, I got a 3007 HC panel that I've had forever, and a friend of mine brought one of those color calibrators over one time, and we did the whole, we did everything, and it was almost not even worth the trouble of reapplying the profile if I reinstalled Windows because it just barely tweaked the colors at all. Yeah. Anyhow, on the display lag thing, it's actually something worth noting is that screen probably doesn't really have any actual anything you can notice as far as gray to gray or gray to black, that stuff, the ghosting. You just really just didn't see any of that at all, right, Jeremy?
No. I could have occasionally see it during the actual testing with the millisecond clock where there would be a fade of a previous number, but I saw it on the CRT2. Yeah, I saw it on the CRT2. That is the only hint of ghosting I ever saw.
Yeah, so you literally had to take a picture of it and so it's not something your eye is going to catch.
Exactly.
Really. Yeah. And so as far as input lag though, it's that's actually pretty standard, 1 frame worth of input lag, right? The only way you can get better than 1 frame of input lag on any kind of an LCD, especially a 30-inch, is you would have to go with a really dumb panel, what's called just a dumb panel. That's one that doesn't have any kind of on-screen display, no mode switching, nothing. You literally have to look for a panel with only a single dual-link DBI input and nothing else. Because any other kind of panel is going to have some sort of processing going on where it has to receive that whole 1 frame from whatever the input is before it can paint that frame on the screen. So that's the reason that you're always going to see at least 1 frame of a lag. So with the 3007 panel, for example, that was the first 30-inch model that Dell came out with. That one only has a DVI in, and then there's a couple of other manufacturers that had their first run 30-inch panel, whatever that was, that only had that 1 input. Those are the only ones you're going to get better than that input lag on, just as a point of reference. So it's not as good as it seems, kind of backwards, right? That the panel with just 1 input is actually better in at least one respect than the panel with 20 inputs like this one is, or however many insane number of inputs it is, but it's just something you just sort of have to live with. And it's if it's just 1 frame, you have to be a pretty hardcore gamer to even, for that to be a deal breaker for you. I would imagine.
Well, it is only about $1,500 or so. So if you aren't sold at that point.
And in one point, I did look up the specs. It is CCFL. It's not.
I need better notes.
LED.
Okay, well then it's got to be a wide gamut. Maybe not necessarily the HC or the LG made HC class backlight or whatever, but whatever it is,
it's considered an HC plus. Yeah. So,
okay. Yeah, it was like, what was the number, Jeremy? It was like 90-something% of the gamut. So it's...
No, it was like 107.
137 or 117.
Oh, so that's even... Okay, so that's even better than... Yeah, that's covering the whole gamut. That means basically your blues and your reds are actually going to look blue and red, not baby blue and orange, which...
And your snozberries will taste like snozberries.
And actually, if you're listening to this and you're just looking at like your LCD at work or whatever cheap thing that they stuck on your desk, or if you just have cheap panels, then you don't even notice, really. The only time you would notice stuff like that, like the colors being off and not having the full gamut, is just because if you were trying to compare something with, say, a picture side by side, or if you're doing photo editing, that sort of thing, and you like really have a critical eye for that kind of thing, then you're going to notice. So those are the kinds of people, if you're actually doing photo work, video work, things where you need your screen to look exactly like the printed result, that's why you go for the wide gamut kind of thing. And this is, 30-inch panel.
Either that or just take the paper to your damn screen.
Well, I don't know. Yeah. Pass the beer coaster test.
What, did you ninja throw a beer coaster at it?
No, one of my tests was actually to match it to a real live beer coaster because that was the only thing I could find I could balance on the screen next to the picture of it.
Wow. So anyhow, yeah, if you're going to spend $1,500 on a panel, it better show you all the color range. And a point on that, now I don't know if you saw this, Jeremy. You might not have just with the testing that you did, but if you get a good enough detailed, like something you're trying to show on the screen, or say you're trying to show like a sweeping, like a fading color or something like this, just a light gray to a darker gray, when you have 30 inches to see that transition go across, at 24 bits per pixel, you're actually going to see lines, like where it's going from a shade to another shade, because you just have so many pixels across the thing. So I can see where you might actually want to do like a higher end card and a 30-bit per pixel, display port,
yes,
all that stuff. Just because there is actually a way that you could see that it's like, oh wow, there's actually, you can't really dither this any better than it is just with, the mere 16 million colors or however many you have with the. It's funny we're joking about this, we used to have like 256 colors and crap, but anyhow, I digress.
Oh, there's only
that you have.
But we do technically, in theory, have another review up this week of something we're all familiar with, but perhaps not at this speed.
Would you like me to take it away? Well, this Monday evening, Tuesday morning, AMD released their final Phenom 2 speed bump /grade/bin. Now I'm getting into Linux. Damn it. Anyway, the Phenom 2 X4980 is the fastest quad-core processor that AMD has ever put out. Now, it's not quite the fastest processor because if you remember, the X6 1100T had a turbo mode that 3 of the cores would run at 3.7 gigahertz, which is the same speed as the 980. But unlike the 1100T, it's got 4 cores and it runs at 3.7 all the time. Now, we had another release a couple of months ago. It was right after CES, where AMD released the X4 975, and this was a, strangely enough, 3.6 gigahertz processor. It's the fastest thing they had, and nobody reviewed it because we got the samples like a week in advance. It was 100 megahertz bus increase. Sandy Bridge was coming out at the same time. Just didn't happen. It was a really, really amazingly cruddy release, and nobody paid attention, including us, even though AMD begged and pleaded. So, because this was going to be the last one, we thought we would say, what the hell? Let's review it. And I did. And the results were interesting. Now, 2 years ago, actually more than 2 years ago, 2 years and about 4 months ago, we had the first review of the Phenom 2 processors, and that was the X6 940 Black Edition. This was their first 45-nanometer desktop processor, and it utilized this new architecture. It competed very well with the Core 2 quads of the time, even though you had to clock at a couple hundred megahertz faster to get, pretty consistent performance. But it had some advantages because it was able to overclock pretty well. It was not unheard of to get 3.8 gigahertz, even if, you were sitting there picking your nose and didn't have any thermal paste with your crappy fan. But it had, better overclocking with water cooling into the 4 gigahertz, and it was setting some speed records with the liquid nitrogen crowd at over 6 gigahertz. So it was a processor at the time that was pretty decent. It kind of got AMD back on the map. They didn't have any major showstoppers like the original Phenom. If you remember, the B2 revisions had that nasty, I think, TLB bug that would only exhibit itself in certain scenarios, but they were important enough to require a respin. And finally we got the B3s. But still, it was just kind of a crappy processor at the time. It couldn't keep up with anything that Intel had. So, the Phenom 2s have been out a long time. I mean, it's been a long-legged architecture for AMD. And the only major change was going from 4 cores to 6 cores with the X6s. And they have consistently been tweaking the 45-nanometer process at Global Foundries. And now we finally have this 3.7 gigahertz monster. It's still a 125-watt TDP part, and so it doesn't pull all that much more power than one of the lower-clocked older versions. Namely, even it's still around the same area as the old Phenom 2 X4 940 that I talked about first. So they've done some nice things with the process. They've kind of tweaked the design throughout the years. And though it's not any faster per clock than what we saw back then, it's pulling a lot less power per clock, and it's not heating up the place. So performance is unfortunate because it's going up against not only the older i5s and i7s from Intel, but it's also going up against the new Sandy Bridges. And Sandy Bridge, it just kind of blows it out of the water, even in price performance. The i5 2400 is around the same overall performance, maybe a little bit higher. Well, actually, no, it is about 5 or 10% faster in performance, but it's about the same price. And when you start factoring in the motherboard costs, AMD has a small advantage there. But when you consider how much more extra performance the Intel part has, it's really hard to recommend the X4 980. It just kind of falls down. And plus, when you consider that we're kind of on the edge of seeing the new Llano-based processors, those should be out in June. Bulldozer looks like it's going to be out in, I would say, maybe July. Don't quote me on that. But it's kind of a strange little release for AMD, but I guess they needed to do it to stay competitive, to keep the name in the news, to keep new products going out, and to kind of keep their lineup fresh. They just actually, the AMD had let us know that they have in fact lowered the price on this card. Originally, this chip was supposed to be $195. Now it's $185. You can pick up like a 975 for $160, $165. And I think that the 955, that old 3.2 gigahertz processor, is going to be headed out the door here pretty quick, and we won't see very much of it left. So when you get around, the $150 to $200 range, not only are these X4s competing with Sandy Bridge, but they're also competing with the X6s. The 1075 you can pick up for, I think, like $155 now. The 1090T is a steal at $185 or $189, and I think the 1100T is $209. And so the prices on these have just dropped pretty dramatically. I mean, if you remember, these X6 parts originally came out at $299, and I really wish that my dog would stop bugging me, but, she's a curious little soul for being 1 year.
And it is a nice leg.
Old. Well, it's her tail flapping around, and yeah, I do have a nice leg. But anyway, it's just hard to recommend this process because the X6s, they have the turbo mode in these lightly threaded applications, and so they're going to run nearly as fast as this X4. And then you do have 2 more physical cores on that when you get into the higher threaded applications, which will utilize them. And, we see the 1090T and the 1100T compete pretty well against, some of the new Sandy bridges and heavily threaded stuff. So, it's a strange little product. The only real bright spot that I had with it, it was, it still ran fine, ran games fine. I didn't see any real issues there or usability problems. And but again, the nicest thing about it was able to overclock pretty easy. Being stock clocked at 3.7 gigahertz, I was able to hit 4.1, I believe, on just stock voltage. I was able to get to 4.3 gigahertz on 1.5 volts. And so, it ran really, really nicely overclocked. It didn't turn into a space heater. My electric bills didn't have any spikes with it, and it performed, a lot better. I mean, you add 500 extra megahertz into the mix, and it has positive results. So, unless you're kind of just worried about that, I don't really see many reasons why you would want to buy this over as compared to, say, wait 2 months and get a bulldozer, or jump in and get a Sandy bridge, namely like, a nice 2500K. That's a fantastic chip for the price. So yeah, it's nice to see AMD again coming up with something. It's kind of fun to see this as, it really is the last of the breed from AMD for the Phenom 2 architecture, but it's awfully hard to recommend this particular product for anybody building a new machine. Now, if you have an AM2 Plus based motherboard that you don't want to get rid of because you've got 8 gigs of this DDR2 RAM that you paid, hundreds of dollars for a couple of years back, then you can pop it in there and you'll have, a nice little speed upgrade from probably whatever else that you had. If you, again, had an AM3 board that you only bought, some months or a year ago, and you may have had an Athlon 2, X2, or X4, or something like that in there, and then this is a nice upgrade for not a whole lot of money that should allow you to play games a little bit faster, a little bit better overclock. But yeah, if you're buying an entirely new system, I would just stay away from it.
Wait for bulldozer?
Yeah.
We all sort of are.
Yeah.
And none so much as AMD, because they had a really nice quarter this year as far as GPU sales go. But when they can really release something to mainstream that is technically an APU, they're going to get the benefit that Intel did when John Petty took a look at this quarter's returns on the GPU market. Ryan and I both posted something on this. Both of us sort of looking at it a different way. What Ryan was seeing was that in quarter 1 of 2011, 83 million PCs were shipped, which is down 5.4 compared to the last quarter 4 2010. On the flip side, shipments of GPUs went up by 10.3%. Now, fully understand, this is shipments. This is not purchases. This is not sales. This is nothing but the manufacturers pushing out chips. It is pretty interesting, though, to see, because we're looking at AMD hitting 24.8, so about 1 out of every 4, which from this time last year is up 15.4%. That is a really nice jump. Intel now owns just a hair over half of the market. They're up just about 10% from last year. That is not because of their new IGP, the new Intel HD that's come out, which is, significantly better than what we had before. You're looking at Sandy Bridge right there, because guess what? GPUs and CPUs now count towards the same market for as far as venture capitalists and everyone are concerned with market share. So Sandy Bridges shipped. That's a GPU shipped. All of this had to come from somewhere. Part of it was SIS, who just hit 0%.
Poor SIS.
I know.
I knew them well.
I kind of miss them in a way. I kind of don't in another. But as far as integrated chips went for a little while there, they were the guys to go to. NVIDIA, on the other hand, is at 20%. That's down 28.4% from this time last year. This is including a brand new architecture launch. This is really kind of nasty for NVIDIA.
Well, they lost all their integrated chipsets on both the AMD and the Intel side as well. So that's
which is exactly where we think this is coming from.
Yeah,
it's not so much that the NVIDIA cards aren't selling. It's that NVIDIA don't go do motherboards anymore. It don't do IGPs anymore. They backed out of the market. It's perhaps not so much of a loss, but in the meantime, the integrated graphics had to come from somewhere, which it looks like is AMD and especially Intel. On the other hand, AMD might have a way to come back to grab a little bit more of the integrated graphics this year because they've just launched a brand new DirectX 11 compliant E6760. Did you read about that at all, Josh?
A little bit. It seems like an interesting little part. It's based on what the Turks core.
Yes.
So it's got 480 stream processors. It's a very, very small chip. It's pretty low power. They keep it clocked down. It's on a substrate that actually has the memory on it as well, but it doesn't have any of the power and VRM type stuff. That needs to be supplied on whatever board it is being soldered onto. It's going to be basically an embedded type processor. And, it's going to be pretty beefy when we consider previous embedded type processors. I think what the HD 46 something was one of the last ones that AMD had put out. And, that was going on 4 years ago. Hard to believe. Maybe, 3. But anyway.
It's been a long time, though.
Yeah, and these, from what I read, that they're supposed to last about 5 years of, having new product available to manufacturers who are going to integrate this stuff into, whatever refrigerator or stove or whatever the hell they're going to use it in that will require that level of embedded graphics. So this is going to be Vegas. A nice little money. What?
Think Vegas.
Oh, yeah, the slot machines.
Yeah. I imagine just how many GPUs they could sell doing that. I mean, it's nice to provide medical graphics. Hey, we're looking at 6 monitors supported off of this. So, yeah, graphics displays for the medical professionals. I'm sure there's a niche market for it, but think Vegas.
Vegas, baby. If you've ever walked in those damn casinos and just hours on end and rows of slot machines constantly being replaced and improved upon, all of your good money going there to American jobs somewhere, I think. Anyway, embedded. Do we want to move on?
We want to jump away from GPUs. And actually, we want to jump away from CPUs, technically. We want to get right down into the raw nitty-gritty of the technology, because when we're talking about billions and billions of transistors, there's a little wall that we're running up against, which, they keep saying, Moore's Law will never be beat because of X. Moore's Law will never be beat because of Y. And now they're just saying, transistor density just can't get any denser until you start talking to Paul Otolini. Who wants to start out on three-dimensional transistors?
Sure, I'll give it a shot. Intel just released today that they're doing the first three-dimensional transistors. Now, it's kind of an interesting way of talking about it because in how they're talking about three-dimensional transistors are sort of always been around. I mean, you've always built it up level by level. You've got the substrates, you got the drain, and you get the stinking big old solid block of silicon on top, acting as a via, and it's they're 3D as well. But this is taking part of the substrate and actually pushing it up into some of these, raised, added on portions. And what this does is it gives a better path for the electricity to go through because, as we're getting smaller and smaller, we get more leakage, all these other negative things that's due to just, the size of the transistors and the current going through them. And what Intel has done is basically put what was once a flat part now has this big old vertical fin in there. And when you actually look at surface area of this fin versus what the surface area would be of this, of the flat portion that would actually be used in the transistor, I mean, it's a significant increase of surface area. So that was a big positive thing. Now, Intel came out with this as it being the greatest thing ever. It's totally revolutionized the transistor, and this is the most significant advance since 1947 when the first transistor was made in Bell Labs by two guys who essentially made it out of Lego blocks of metal and glass, but
centimeter, not nanometer.
Exactly, but it's not dishonest because this is a big jump, and this is something that is allowing them to effectively go to 22 nanometer and still get a lot of the performance and increased thermal efficiency due to the smaller geometries. But we could probably argue that other things have been just as important, like when Intel finally got, submicron type fabrication. Mm-hmm. AMD and IBM and Motorola all were the first to develop copper interconnects. And, I mean, that was a huge thing at the time. That was at 180 nanometer. And, Intel didn't get there until, I believe, 130 nanometer. And but then we have other things like, AMD and IBM did SOI. Intel did the high-K metal gates, dielectrics. I mean, there are lots and lots of things along the pathway that have all been really, really necessary for the entire industry to go forward. And so when we kind of
we've been talking about chip stacking for forever, though.
Yeah,
this is the idea that we can build it three-dimensionally, but the heat problems are just ridiculous. How do you draw heat out of the middle of that three-dimensional chip
stack? And that's it's not something that they have done yet. But if you look at what's been going on with the conversion, and the direction of going to 22 nanometer, a lot of the physics of the materials were causing things to be not as good as they were hoping when it came to power and heat production. And AMD, IBM, and a couple others were all going to what's called fully depleted SOI, which gets around a lot of the problems that just, kind of the standard materials and the partially depleted SOI was going to have at 22 nanometer. Now, Intel did not want to go to fully depleted SOI. They felt that was too expensive, and so they needed to figure out a different way to do this, and that's why they invented this 3D transistor technology. And again, it's not a huge jump in terms of visualizing it or even the concept of it. It's actually implementing it into the process of fabricating a chip. That was really the super hard part about it, and they were able to successfully do this. And the cost savings are about 7% as compared to utilizing a fully depleted SOI solution. Now, with SOI, you need to have these special wafers. And with fully depleted, you have this very, very, very thin top portion that is hard to create and fabricate. And they've finally been able to do that last year in a fairly economical way. But Intel thought, hey, we can do this a lot cheaper and still get all of the advantages that we're kind of looking at, except we don't have to go with fully depleted SOI. We can just use the regular silicon wafers that we've been using for ages, and this is just kind of a way to do it. So AMD and IBM and those guys are not going to be so far behind in terms of power and performance as Intel, but they're going to be paying a little bit more per good chip, because the silicon wafers are going to be more expensive. Now, you may think, oh no, this is a deal breaker, this is a bad news. Well, this is a cost that AMD and IBM and all these other guys have been eating since they first went to SOI wafers, and so this is nothing new in how they're doing their accounting and how they're figuring out the scales of how much it's going to cost. And so I just kind of laugh because, I really respect Intel, because they're the first to 22 nanometer. They're going to have it out in full speed by the end of this year. They've been able to integrate this new technology, this 3D transistor. I mean, all of these are really, really, really big things. I mean, AMD has not even gotten a 32 nanometer part out. Intel has had them out for a year and 4 months now. So AMD, IBM, all these other guys, they're well behind when it comes to fabrication. But this is not the second coming. I mean, it's an impressive piece of technology, but it's not as impressive when you kind of take a look at the industry as a whole. And again, I think I am far more impressed with Intel and its speed of getting to these, smaller and smaller geometries faster than the rest of the industry. I mean, that is something they really should be proud of. But when it comes to AMD and all these other guys finally getting to 22 nanometer, we're not going to see any kind of massive gulf in terms of per transistor switching performance and power overall to the chip and per transistor. I don't think it's going to be all that dramatic between the two technologies. But again, Intel has got there at least 18 months before the next person. And I mean, they're going to have a huge advantage when it comes to actually fabricating lots and lots of chips on this and selling them at really good prices and achieving those 65% margins that their last couple of quarters have been racking up. Alan, you've got some wonderful things to talk about this technology with.
Actually, just for starters, as far as die shrinks go, I think that they're the main push for them now. Actually, not just now, maybe within the past year or two, has been, I think they've all been driven a little bit more from their flash memory branch, because their flash memory just dipped down to 20 nanometers, and they've been doing 25 for close to a year now. Maybe not production grade. That's only been more the past few recent months. But as soon as they got 25 nanometer to the point where we can ship this consumer grade, that sort of thing, we can really beat this stuff up and it'll last a long time. They're already taking the jump to 20, right? So I think that's sort of helping them drive their die shrinks elsewhere as well, like whatever innovations they have to come up with to figure that out, right? Because it's not, the flash memory is not just such a simple thing, right? It's actually, you can almost argue that the power delivery part of it is a little more demanding than just your typical CPU, because when you do the program mode on flash memory, it sucks down a lot of juice to a very small area. And when I was walking around their fab, I think to make the 25 nanometer stuff work, I think a few steps to that process include copper, and I'm not talking just for the interconnects. I think they're actually throwing copper into the layers to be able to conduct, pass that current well enough without it being an issue. So that's just one part, just on the really small level. Now, also on the small level, though, this is a really big difference from making a field effect transistor standpoint, because your typical FET is just it's a field effect thing. Okay, so it's for a FET to work efficiently, it's all about surface area. and it's all about not just surface area, but since they're taking this channel, the channel used to just be flat, right? So it was on a substrate, it was completely flat. They would throw the gate on top of it. So really, all you were covering was half of the channel, right? Anything on the bottom on the substrate, it just had to you had to rely on, okay, is there enough field penetrating through from the top layer down to the bottom? So the effect was, depending on how efficient it was or how well they can make that particular FET, where you lose your efficiency and where you get your heat production and all that other stuff is that when you try to turn this transistor off, basically imagine it's sort of like a floodgate thing with a gate that goes up and down. That's basically sort of how it works, almost like a dam, right? Except in this case, instead of water, it's just a flow of electrons. Well, if you're trying to shut that thing off, in other words, you don't want power going through whatever that transistor is, if the field is not completely efficient, right, you get a little bit of leakage through there, and that equates to heat production, right, because then you have a flow of electrons through a resistive path, which gives you, the end result of that is heat. It's basically just wasting energy. So that's the kind of stuff that gets in the way of overclocking, causes you to have, you have this little bit of leakage. Well, you multiply that out by millions, right? And now you have there's your idle power draw of a CPU, basically. Even if you shut off some of the cores, you can't necessarily shut off all of them all the time, right? So anytime any of those cores is on, you have that leakage times, whatever, hundreds of thousands of transistors all in parallel, which is a really bad thing, right? So if you completely restructure a FET like that, I'd almost venture a guess that even if without the step to 22 nanometer, I couldn't even imagine how good this would be if they did it on their current process, right? Not the 22, but what was the prior step? Josh, do you remember?
Say that again.
What was the prior die shrink before 22?
CPU or SRAM?
CPU.
32 nanometer, 45 nanometer, 65, 90.
Okay.
130.
So if they were to do something like this on 32, realize they're only doing this on 22 to be able to negate a lot of the other side issues you get with the die shrink, right? Disadvantages. So if they did something like this on 32, that CPU would probably be almost competitive with ARM. You could probably get it there because it's such a drastic change. Basically what they're doing is instead of the channel being flat, now the channel is vertical. It almost looks like comb teeth, I guess, if you look there's a bunch of pictures on the Intel site, but they're wrapping the gate around, they're basically standing the channel up on its side and they're wrapping the gate around it. So all you end up with is just one sliver on the edge, on the bottom edge, that's not, completely covered by the gate. So when it comes to turning this thing on and off, when you shut it off, you're going to have a lot less current flowing through it, comparative to the old school style of how you made a FET. And like what Josh was saying, it's impressive that they were able to make this kind of jump. I was surprised to see that they were able to drop all the way down to 22 from 32 in the first place, right? But not only did they do that, but they're doing that and all the transistors, or the vast majority of them on the board, are this completely different structure. That's a pretty insane jump to make.
Yeah, it's huge.
Yeah, because think about it. They've been making transistors physically. Aside from the strained, unstrained, whatever, all those other advances they made in the silicon itself, the physical structure of the FET has been virtually unchanged for a long time, right? Whenever it comes to
40 years. Yeah.
Well, anything that had to do with an actual on a chip, right? Now, there are FETs you can buy where it's just one field effect transistor and it's in a big old package and it handles a couple of dozen watts, that kind of thing, right? That's obviously going to be made a completely different way. But anything that has to do with a lithography way of making transistors and any kind of field effect transistors, it's been the same. So, yeah, I almost would have expected this change to happen with them staying on the same die, on the same nanometer size. But, yeah, it's really how the heck did they pull that off kind of thing.
A lot of money and a lot of talented engineers.
Yeah, I bet there's any margin they make on those CPUs for a little while is going to be recouping 10 years worth of R&D and everything else I had to do to do that. And that's actually a lot of what that's a lot of what Intel, they sort of like borrow from themselves.
What's the benefit of being the gorilla of the market? You've got the money to toss into R&D for that long.
True. And you can bet that they're like, same goes with their flash memory, right? To get to 25 nanometer, they had to dump a crap load of money into the tools, everything in the plant, that sort of thing. And I bet they had to do another round of that for 20, to shrink that much further. So the reason you don't see like SSD prices instantly dropping because, I know they can make these things for 50% cheaper now. Well, no, they got to make their money back first. So some of that profit they're making isn't really profit. It's, they're just paying themselves back basically for everything they had to invest in all their fabs and everything.
Well, we've got you on screen. Something right up your alley, not my Vaseline smeared alley, apparently.
That's really out of focus drastically.
My connection is gone. Seagate has jumped to a terabyte per platter, have they not?
Mm-hmm. It's the Canadian Border Patrol. They're blurring your image for you as the packets go across the border now.
They don't want to know where he's living. The helicopters can't get him if he's out of focus.
That's true. At least they're not delaying him by 30 seconds. They're just dropping him completely. So I guess we'll just deal with what we got.
Put on my tinfoil hat. We'll see if that helps.
Yes. Wrap the tinfoil around the webcam, Jeremy. All right. So Seagate has dropped down to 1 terabyte per platter, which is pretty darn good. That means they can make a 3 terabyte drive with 3 platters, which is exactly what they're doing. Something that caught my eye, which I don't know.
Other than fishhook?
Well, yeah. So what I'm hoping is, A, that this is not a 7,200 RPM drive, but if it does happen to be, at least it's only 3 platters and not 5, like I believe was their original 3 terabyte solution. It was either 4 or 5. I'm pretty sure it was 5, though. They sort of had to do this, especially since the first drive they're pushing this out in is the GoFlex series, which is their external drives, because their first 3 terabyte external drive, if you wrote to it for more than, say, 5 minutes, the thing would cook inside the external case because it was like, 4 or 5 platter 7,200 RPM drive. So any kind of write duties to it, and the thing literally, the external case was like an insulator almost. It was like this perfect. If I wanted to make like a koozie for a drink that would keep my hot chocolate hot for a long time, I would make it like that. That's how they made the case. It had like no vent holes on it, with a drive inside and a nice air gap around it, and the drive was like wrapped in foil and like all this other stuff. It's like how we really want this drive to cook. I think they misinterpreted the term cook. Should have meant like performance cook. Anyhow. So hopefully this one will make less heat, and they'll be able to have a better performing external solution. I would guess in a few months after that starts shipping, they'll probably come out with an internal solution that's using the same, the same kind of platter design. They usually tend to just roll that stuff from external to internal. It didn't used to be the case. It's kind of weird. Ever since the 3 terabyte models have come out, it seems that the first thing that comes out is the external solution. And that's mostly because not everybody is up to speed on their motherboard and chipset that can handle a greater than 2 terabyte drive natively. That's still sort of playing catch up. So since that's a slimmer portion of the market than the people that just want to back their stuff up onto a huge drive, then that's why we see the external stuff coming out first. Same with Western Digital. They did the same exact thing when their first 2 terabyte came out. However, Western Digital's 2 terabyte drive, granted, while it does spin slower and it makes less heat, it is only 4 platters and not 3. So I guess Western Digital is lagging Seagate a little bit. But to Western Digital's benefit, their drive doesn't have any kind of heat issues, so they can sort of afford to just stick with what they've got. Their drive performs just fine with the slower platter speed. So yeah, there's news from Seagate.
It's funny. I remember about 7 or 8 years ago when everybody was talking about the jump to perpendicular writing on these drives, and they had that wonderful little song, "Get Perpendicular." Get perpendicular, and these were like 160 gigs per platter. It was breaking all kinds of records there.
Yeah. What's
and
funny is now that's just the run of the mill. I mean, all the drives are using that. Just that tech is just that it is what it is, right?
You were talking earlier with the 3D transistors, Josh, about sea changes in the industry. Perpendicular recording that was one that just really took off, wasn't it?
Yeah, it was big, and it allowed a much denser hard drives for us back in 2003, 2004. It's a big deal.
Yeah,
I remember getting my first 320 gig hard drive and thinking, this thing's the bomb. I'm perpendicular, man.
This 3D transistor thing, actually, there's one more point I meant to bring up on that. I sort of see Intel. You know how Intel sort of backed off on their being all restrictive about overclocking thing lately?
Mm-hmm.
Right? They went through like a spell of, we don't want, and they started locking down everything like crazy. And then even the Sandy Bridge stuff, you can't really multiply or overclock those things anywhere near to the degree as you used to be able to, right? With like, say, Core i7, where you could just go 30, 40%, 50% overclock just based on ramping up the front side bus. So even if the chip was multiplier locked, it didn't matter because you could just ramp the whole system up, right? Sandy Bridge moved away from that, but there are K-series CPUs and there are unlocked CPUs with, you can just basically say, I want this multiplier and whatnot. I think with this 22-nanometer stuff, they're going to get more restrictive on it again because it's going to make the darn thing so efficient that you could just I think you could easily get a 50% overclock out of a CPU that was doing that sort of thing, unless there was some other limiting factor, somewhere else in the CPU that's actually causing it to, the thing that's going to make your system become unstable overclock-wise. But if the majority of that CPU is doing these completely different kinds of transistors, that's going to be a big difference, right? I mean, like 50% efficiency increase. That's huge, right? Any crazy overclocker, if you told them you could just like get half the heat out of your CPU. Think of all those guys we saw when we were in CES, right? That overclocking competition. Imagine if everybody's CPU there was making half the amount of heat, right?
MSI would have twice the amount of competitors for their overclocking competition.
See, it's Moore's Law, damn it.
Yeah. Those guys would have been turned in much higher numbers for their world records. I'm telling you.
The guy must have been a time traveler because no matter what he does, he's set a bar where these companies will do whatever it takes to keep up with it. And I love it because you keep seeing these new things come out where, oh no, there's a wall. They'll never be able to break 32 nanometer. Guess what?
Not only did they break it, right, but there's a demo video from Intel where they're showing a mobile, a desktop, and a web server platform running on the 22 nanometer. So this isn't just like, we have a die in a lab. No, they're running it on not just the silicon, not just on a test bench. It's like 3 systems up and running on 22.
Well, yeah, when we were at CES and we were talking to Intel, I asked them, so how's 22 nanometer going? And all their eyes just lit up. Oh, it's going really well. It's well ahead where we were expecting. Things are really, really popping. They were excited about it. They couldn't wait until the first 22 nanometer stuff because they are so far ahead of the curve as compared to everybody else in the world. And they're billions of dollars.
This opens up some other doors here. If they're able to, lithography-wise, if they're able to pull off a 3D FET, they're going to start making other parts of that chip 3D. Maybe not like 3D to the point of stacking stuff on top of each other, but if you can start vertically orienting a lot of those other components of a chip, not necessarily putting components on top of other components because that you get into your heat issues and stuff like that. But man, if you can take some of that stuff and apply it to some of the transistor tech, that's because there are transistors in like flash memory, right? The actual bit itself is just a channel that's insulated. Okay, so that's just like a little hunk of an insulated silicon sitting in the middle of a couple of gates. But if you can like 3D orient more of that stuff, then it's almost like you might start seeing steps where the next step for flash memory might just be, oh, by the way, we can get 50% more on the same die size, but we're staying at 20 nanometer, right? Or even maybe do the same thing at 25, where it's just like, we can make this thing that's as good as a 20 nanometer chip. but it's actually 25, and it just happens to hold twice the capacity because we just started stacking stuff on its side. So almost, if you will, the go perpendicular thing from hard drives could just carry over to the chips. Right? Because right now everything's flat.
It's just to keep going on with that, I think the jump to 14 nanometer is going to be tough, and that's primarily because of the actual lithography issues that we're getting into. I mean, we still haven't really effectively developed this, deep UV technology. They're looking into X-ray type litho. I mean, 22 nanometer, it may be here for a while until we get some of the optics and litho stuff figured out. I mean, they're getting there, and they're spending billions of dollars on doing it. But, yeah, I think the jump from 22 to the next node is going to be a really rough one.
Yeah, well, you're using light etching, so you got to pick something with a little itsy-bitsy bandwidth.
And what's crazier now is that, I mean, even for 25, a lot of their process for the flash memory, most of it's like a wet process now. Like you can't even have.
It's all immersion litho.
Yeah, it has to be immersed because between the lens and the die, like you can't have an air gap. It's like to that point where they're basically the liquid is considered a part of the lens structure to be able to
focuses it.
Yeah, to be able to focus.
UV is like 300 and some nanometers. Like you've really got to focus it and beyond.
Right, yeah.
Yeah, actually, I think 180 nanometers is the current light that they're doing, but they do, other kinds of tricks to get that to focus down on, the stinking, 22 nanometer. Well, 45 was kind of the last dry process. But yeah, I mean, there's a lot of tricks that they can do to get that focus down, even though the actual wavelength is much, much larger than the smallest features. But yeah, we're running out of tricks to do.
We hear that a lot, though. That's what's funny.
Exactly.
Yeah, and they
always
somehow
say, they're running out of tricks. There's a brick wall, and we said that at like 100 and something nanometer.
Yeah, it's nice to see that the engineers are continually springing tricks on good old Mother Nature and physics. So we are on to picks of the week, unless we want to go back to the 3D transistors again, which, honestly is worth it because it's an interesting pick. But for Ryan, since he's not here and his lawyer sort of paid for him to go to the Virgin Islands, which I'm pretty sure doesn't have an extradition treaty, so we're not quite sure what he did, but good luck on him, and I think Ryan is picking his lawyer. Myself, I had a lousy day at the office, which is part of the reason I am just so bloody exhausted today, and was quietly sitting on the couch petting my cat when I had an old memory pop up, which is officewarfare.com. officewarfare.net. If you've never encountered this site before and you got a little bit of a predilection for playing pranks and the ability to log on to other people's computers via command line, there are quite a few good-natured pranks that you can do with it. But that requires some programming, and, I don't necessarily have complete control over the domain that I'm on, so I'm then thinking hardware because an old post was just resurfaced not too long ago with a little USB that you just rewire a little bit, and it randomly toggles the caps lock on and off. As long as you sneak it into the back of a guy's PC, he's not going to know why it is he's typing in caps occasionally. But seeing as how bloody tired I am, I did remember that ThinkGeek does still have the Phantom Keystroker version 2, which is a nice little USB device that you don't have to program, you don't have to solder, you just have to plug in. But I'm telling you, when you've had a bad day, take revenge upon those who inflicted it on you.
You're a classy gentleman.
Yeah. My pool, it is dirty.
Anyhow, my pick. I kind of talked about it a little bit earlier. The combination of that MSI 890 FXA-G65 with one of the newly lower-priced 1090T is just a combination that I would find hard to resist at this point. I mean, it's not a whole lot of money at all. You can use it as a gaming machine. You can use it as a workstation. You could have it as an absolute dirt cheap but still incredibly fast VM server. It's got a lot of VM circuitry in the processor itself, and it's got the IOMMU in the 890FX chipset. It's just hard to ignore something like that is that cheap, and you can use it in so many different ways, and it will be, even in the face of Bulldozer and Sandy Bridge, it will still be an effective platform for a large variety of applications for quite some time. So that's my pick. I think if you just want to pick one up for cheap and build a new machine for yourself, you're going to be pretty happy for a long, long time to come, no matter what portion of those three applications that I was mentioning you would use it for. So there you go. Dirt cheap. Just like me.
Do you have 6 cores?
You don't want to know.
Fair enough. Alan, do you have a pick?
Did
you run away again?
Sort of a dirt cheap pick. But first, a thing from our chat amongst ourselves earlier today, go to Google and look for Portal Tetris if you want quick entertainment for a few minutes.
That's another prank I was thinking of pulling on people.
That was pretty cute. Someone should just make like a full-blown, well, that is sort of a full-blown, but someone should make
That's the whole game right there, man.
So yeah, there's not really much to it, right? I just wish there were still gaming consoles out. Like, I wish Portal was around 10 years ago so you could, like, recode someone's Nintendo cartridge.
Well, it was called Narbacular Drop.
I don't know. So anyhow, along the lines of cheap stuff. Okay, so a couple months back, 4 or 5 months back, I threw, like, 4 bills at a home theater PC, one of those ASRock things when they first started coming out. And, Ion, Intel Atom, that sort of thing. And I built myself a little box and threw it on top of the television and, called it a day, right? And so kids watch their movies on there. We watch movies on there. Pretty good. You can get a high-definition output, HDMI, that sort of thing, out to your television and play just about anything you want, right? Hulu, Netflix, everything. All right, so there is a thing you can get that's only $100 that you can make do all the same stuff. It just requires a little bit of effort. Okay, so the thing's an Apple TV. They sell them for $100. I think Apple sort of subsidizes them because they expect you to buy a bunch of content off of iTunes, which probably a good chunk of the people might be doing with the thing, so they can afford to get away with selling the piece of hardware for $100. You don't have to necessarily do that, though. Nothing stops you from going into an Apple store and $100, you get this box. They're not going to force you to buy the content from them, right? So you get the thing home, and first of all, you could just use it right on Netflix if you already have Netflix and just go with that, right? And then there's an awful lot of stuff on Netflix to watch. Hulu is a bit trickier. I'm at the interim step, which is where you take the Apple TV 2. Most of my systems in the house are on Windows, so the regular dev team blog style jailbreak for the Apple TV 2 you have to do under their tool that's specific to Mac. And since it didn't want to work with my virtualized Mac OS X that I use, which I've gotten away with doing some of that kind of stuff in the past, like you don't necessarily have to have the Mac to do the Mac OS X stuff. That didn't want to play nicely, so I just used the other version of the jailbreak, which is called Season Pass. So it's Season Pass with the 0. You take that. There's a Windows version. You run that thing. It downloads the most up-to-date build from iTunes, straight from iTunes, and then it just like reworks that module to include the jailbroken stuff. It's an untethered jailbreak. There was some complications where you're like before, in order for it to be jailbroken, you had to like boot it with it plugged into a computer, and it was a big pain in the butt. The current version, everything as it stands right now, probably as you're listening to this. The jailbreak is untethered. Basically, it's as if you bought it, right? Once you're done with that jailbreak, it's like its own thing. It's done. You don't have to do any other kind of maintenance to it. So once it's jailbroken, the really, really cool thing you can do is, and this requires a little bit of like DOS level knowledge. So if you used to be like a guy hacking away with config.sys and autoexec.bat, you would be just fine doing this. Hopefully you're one of those types.
Otherwise, why are you watching us?
Yeah, basically. But you SSH into the Apple TV, right? The jailbreak enables SSH, and it basically just turns it on. So you can just do that. And once you SSH in as root, you run a couple of commands, and basically you just apt-get Xbox Media Center. Now what's funny is I'm using the term Xbox when we're talking about an Apple TV, but Xbox Media Center is a Media Center app that used to run on the original Xbox. It was the reason that a lot of people would mod that thing, because you could take an Xbox and stream any kind of media off over your network. So if you have a media server or any even just your PC with a shared folder on your network is really all you need, and you just stick all your videos in there, you could share them to what used to be only an Xbox. Well, the Media Center app got so refined over the years and it was open source, and so it ended up getting ported out to by like everything. So Xbox Media Center got ported over to PC. Wasn't necessarily that popular there unless you were running it on a home theater PC. I tried it on mine, on my home theater PC box. It was, it was decent. It was cool. The really cool thing is that the most recent builds of it on the Apple TV 2 actually used the hardware decoder. Right, there was an iOS update that did something with APIs that had to do with hardware decoding of video, and Xbox Media Center on Apple TV 2 uses that decoder. And I think, and I might be completely out to lunch on this, but Apple TV 2 is supposed to only do 720p. My TV is like this really old school rear projection CRT Mitsubishi that doesn't support 720p as a resolution. And I was pretty sure I saw it mode switching, so I think under Xbox Media Center it was switching from 480 up to 1080. I think under Xbox Media Center it actually pushes the output to 1080. Again, I could be like out to lunch on this, but it seemed like something was going on there where it was switching. So it might actually push the Apple TV hardware higher than iOS is supposed to allow it to go, which would be really cool, because that, if it is actually doing that, it means you're actually watching a 1080. The only catch is to realize is that if you have an older TV, you only have an HDMI out on the back of an Apple TV 2, and it doesn't have an audio out, like a regular microphone jack audio out. So I was using a home theater PC HDMI to DVI converter because it was an old school television. It only had DVI in. And I was just getting my audio out the headphone jack and just converting it to RCA. So you have to go the long way around. There is an optical audio out on the back of the Apple TV, but you have to have something that's going to receive that as an input. I'm just going to pass it through my receiver, no problem, but I had to order a cord. That's the other thing to realize. Apple TV, they don't include any cords. It's only $100, so they're not going to throw an extra, $5 or $10 worth of cords in there for you, unfortunately. But anywhere online, you can find like a Toslink optical audio cable for like less than $5, and a DVI cable or HDMI cable for like less than $5. Or in my case, an HDMI to DVI converter cable. Anyhow, so $100. It comes with a remote. Once you've jailbroken it and put an Xbox Media Center on there are ways to get Hulu to stream as well. Once Xbox Media Center is on there, there's all sorts of a plugin structure for Xbox Media Center. So it's like once that's on there, you're just golden. You've got you can basically stream anything that you want. So with this really tiny box, you're just, sky's the limit basically on what you can get to your television. And this thing's so small that you could literally have this thing like if you had a wall mounted like those new Samsung panels. Like Samsung's making like a 55-inch LED LCD TV now. The thing is like not even a half-inch thick on the panel. So that's like screaming, mount me on a wall. So you could take that and just have like an Apple TV just like sitting barely off to the side of it on like a tiny shelf on your wall or something.
So a TV is Screaming, mount me on the wall.
Yes.
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 I love how the Navy guy gets away with that, but you or I, Josh, said that?
If it was light enough, you could probably just pin it to the wall. You know.
Good Lord.
Okay.
Screaming,
this
mount
is a submariner. Josh or I
Yes.
could never say that on this show.
No.
Leave it to the Navy guy, right?
Yeah.
Anyhow, that's my pick. $100. I'm literally gonna like sell off my home theater PC box because there's no use for it anymore. I might just like make it my kid's computer or something.
Just don't mount it on the wall.
No.
No. Not
No.
in front of the kids.
No, not in front of the kids.
Well, if you're still actually watching this, and Ryan, I bet you're not, this has been the PC Perspective Podcast, the 153rd PC Perspective Podcast. If you actually want to watch it again, or you want to catch any of the 152 previous episodes, we're at pcper.com/podcast. Or if you want to send us an email or voicemail, we're at 1-888-PC-PER, or 1-888-38-PC-PER, or podcast at pcper.com. If you're more of a stalker type, you can stalk Ryan at twitter.com/Ryan Shrout, or twitter.com/PCPer. He checks them both all the time. With that, I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Al Malventano.
Mount me.
No.
Just